Hello everyone. Um, you've asked me to solve this exponential question. Specifically, you were asking me to solve it using logs, but I thought we probably will benefit if we see that this particular question can be solved in both ways, either using logs or simply using indices, rules, and exponentials. So I'm going to do, I'm going to use it, I'm going to use exponential or indices method first, and then finally we do the log as well. So maybe we use part of the screen to do one, and then the other part to do the other method. So as you know, 9 can be written as 3 squared. So we have really on the left hand side of the equation, we have 3 squared, which has been raised to the power of 3x minus 2. And on the right hand side of the equation, we have 3, which is raised to the power of 2x plus 7. So using the rules of indices, you know that if you have a power outside the bracket, then that power will multiply itself into the powers inside the bracket. So really on the left hand side of the equation, we have 3 to the power of, so I'm just going to write the power without the bracket now. So it'll be 2 times 3x, which would be 6x, will also 2 multiplied by minus 2 in the bracket, which gives you minus 4. And that is equal to 3 to the power of 2x plus 7. So since we have 3 raised to powers on either side of the equation, and the equation is in balance, then it means the powers themselves have to be equal. So therefore the power 6x minus 4 must be equal to 2x plus 7, which that would be just a simple linear equation to solve, which means 4x would be equal to 11, and x would be equal to 11 over 4. 2 3/4. Yeah, 2.75. So that was dealing with it using exponential. It's not always easy in a way that we did it here. So on one side we had 9, which is 3 squared, and the other side was 3. So the base is not always the same. In this case it was the same, but the bases will not always be the same. And if they weren't the same, then we can simply use logs. So I will apply the single log to either side of the equation. So when I do that, I would get, let's do it in a different color. So I would get log, this is log to the base 10, but I am not going to write the base 10 because we know that it is when it's not written, it is log base 10. So it'll be log of 9 with the power of 3x minus 2, and that will be equal to applying log to the other side of the equation. So that would be log of 3 to the power of 2x plus 7. Both of them are base 10. Now, so as you know the rules of log, the power in the log can be written as the coefficient. So the power, this power here, can be brought out and written as a coefficient. Now, this power is not just a single item. This power has got 3x and it has minus 2 in it. So it's got like two parts to it. So I'm going to bring it out as a coefficient, but I am going to put it in a bracket, making sure that we know that 3x minus 2 together, they were the power. So log of 9 is equal to, so bring the power of the other one, put it as coefficient, so that would be 2x plus 7, and that would be log 3. Yeah, let's write the 2x a little bit nicer so it's more visible. So 2x. Now, so what we can do here, since we have, since we are lucky enough that log 9 and log 3 are related to one another, what we can do here is to get the log 3 to this side and divide them by one another. So you would get 3x minus 2 and log 9 divided by log 3 if you type that in your calculator. So if you type log 9 and then divide that by log 3, you will see that the answer is 2. So this is multiplied by 2 here, and on that side you would have 2x plus 7. And so then it would just be a simple expanding of the bracket and solving the equation. So again, you would just arrive at the point where 6x minus 4 is equal to 2x plus 7. And as you know, we solved it here. So it's the same solution. So x would be equal to 2 3/4. Yeah, so we were lucky here that the bases were the same. So we could have done it either that way or that way. We were also lucky that when we did log 9 divided by log 3, we got a nice answer 2. It doesn't always happen like that. But if it didn't, it didn't. You know, numbers could be not straightforward numbers. We can still deal with that. So that's another situation. On the surface of it, it may not be apparent that they can be written as a single base, but it can. And 25 is 5 squared. So it's 5 squared to the power of 3x minus 2. And on the other side of the equation, 0.2 is 2/10, which is actually 1/5, which in fact is 5 to the power of minus 1. So 0.2 is in fact 5 to the power of minus 1, and that has been raised to the power of 2x plus 7. So as you can see, they both now are in the same base. So this would be 5 to the power of 6x minus 4 equal to 5 to the power of minus 2x. So I'm multiplying the powers outside the bracket and inside the bracket. So minus 1 times that gives you minus 2x, and minus 1 times 7 gives you minus 7. So since the bases are the same, I can make the equations the same. So 6x minus 4 would be equal to minus 2x minus 7. And so 8x would be equal to minus 3, which means x would be equal to minus 3/8. Yeah, we can do the same. Let me just squash this to one side so we can, yeah, squash it to one side so we can maybe use the other side of the screen to do it in log, using log. So applying log to either side of the equation, you would get, so I'm just gonna, since we explained that before, so if I apply log to both sides of the equation, I get the power become a coefficient. So it'll be 3x minus 2 log of 25, and that will be equal to 2x plus 2x plus 7 plus 7 and log of 0.2. Log of 0.2. And as it happens, if we bring the log 25 to one side, if you divide the log 0.2, so if you do this on your calculator, log 25 divided by log 0.2, so I did that on my calculator, so I get a fraction. On the top I type in log 25, and in the denominator I will put log 0.2, and you get minus 2. So in fact, if I do, so let's just keep this for a reference. We'll make it little and put it here on the borderline, and put a little cloud around it, so it just reminds us that we're going to multiply that by that. So if I bring this over here and divide it by it, so you would get minus 2, so it would be minus 2, which is multiplied by 3x minus 2, and that will be equal to 2x plus 7. So we multiply that in, you get minus 6x plus 4 is equal to 2x plus 7. Can bring the minus 2 to this side, so you get minus 8x is equal to 3. So hence x would be 3 divided by minus 8, which is again a minus 3/8. Yep. Okay. That was the solution of these two equations. There's equations that I'm going to do more on logs, and I'm going to maybe next I'm going to do logs, exponential questions where the numbers, the bases can't be made the same. Just like here, we could make them both to be base 5. It doesn't make any difference. It just makes this division that you have, it makes it a little bit more awkward to deal with because it will not be a straight number. So I'll see you on my next video.